Is February 1st, 2021. It is the 21st week of our remote instruction using Canvas. This starts the very first day of the second semester. Okay, so the third 9 weeks starts right now, today. To get started today, I want to make sure that we understand that Thursday and Friday were those makeup days, and we really haven't had direct instruction with the parts of the atom and atomic structure since Tuesday of last week. So what I'm going to do today, instead of starting with the Adams Family practice packet, which is going to be something I think we can wait until tomorrow, and hopefully tomorrow we'll be back on live lessons that we're going to do. But what we're going to do today is just watch a little video I had planned for, I guess it'd have been this Monday, but it would have taken into account that we were going to be in class Thursday and Friday. So this would have been more of a review, but it's going to serve as a review today anyway. So what we're going to do the onset first, and then we're going to go down through the week and what we're at least tentatively planned on doing. And then we're going to watch as much of the video as we can within a half hour. It takes about 25 minutes. This is one assignment where you might have to finish this outside of this half hour. Okay, so I'm going to present my screen. In a few seconds, you should be able to see what I'm seeing. And then we're going to go through the onset. I'll give you a little bit of time. This onset today is going to be a little review of heat and temperature. Okay, so watch there it goes. Okay, so you should see my Canvas page, our Canvas page for science. Since we had like kind of an unofficial snow day, okay, this is one we won't have to make up, so that we're going to go to modules. And under modules, go down to week 21. And I put a little thing here that says the first week of the second semester. Kind of feels good we're kind of on the downhill side of the mountain, so to speak, for the school year. Okay, and then we're going to go down to Monday's onset question. And I'm going to click on that, and you guys click with me. This comes out of the old textbook here. These are standardized test prep questions, number 1 to 3. This is going to review what we looked at with heat transfer. Okay, and this kind of goes back to the lab of heat transfer when I took the hot water and the cold water and put them into two containers together. Okay, so you're going to look at the 2 graduated cylinders. Each one of the graduated cylinders have a thermometer stuck in them. And then you're going to answer the 3 multiple choice questions down here from the book. Okay, so I'm going to give you a few minutes on that, and then we'll go through this. Excuse me. Your answers today are just going to be A, B, C, D, or F, G, H, I, depending on what number you're on. And then you're going to type those into your reply box. So 1, 2, 3. Okay. So I'm going to give you 2 minutes to work on that, and then we'll get into looking at these a little bit. And if you have any questions, you can ask me. Okay, but try these out. I don't think it's that bad. This should be a review. Okay, nothing about atoms just yet. We'll get to that soon enough. Okay, do this now. Okay, first period, another minute. A few more seconds. Okay, now number one says, which graduated cylinder contains more water? And this is almost like a trick question, but you're going to look at the volume of the water in each one of the graduated cylinders, and that would be the gray shaded part of the graduated cylinder. And to me, it looks like it's at 10 milliliters, okay, for both of them. So the best answer for number one would be C. The cylinders contain equal amounts. So number one has to be C. And like I said, that was almost a trick question. Number two, if the two cylinders are touching each other, what will happen to the thermal energy in the cylinders? We learned with heat and temperature transfer that it's kind of like a downhill kind of slope where the thermal energy is going to flow from the warmer temperature or the warmer object to the cooler object. So if the left cylinder, one on this side, is at 50 degrees Celsius and the one on the right is at 20 degrees, it's going to kind of go down this way. Okay, so it's going down from 50 down to 20. And that's how the thermal energy is going to kind of flow and transfer from warmer to colder. Okay, it doesn't go the other way unless you add energy to it. And we're not adding energy to these, we're just sticking them together. Okay, so if we took two cylinders and put them side by side. So it's going to go, I would think, from letter F. It will pass from the left cylinder to the right cylinder. It will go from 50, and that energy, that extra energy, that thermal energy is going to transfer into the 20 degree cylinder. Okay, so number two is F. 2 is F. And number three, if the water in the graduate cylinders mix together, which of the following will most likely be the temperature of the mixture? So if you took these two, dump this one into this one, what do you think would actually be the closest temperature? When you're looking at this number three, you want to get somewhere in between 50 and 20. Best answer I can see would be B, 35 degrees. Okay, B, 35 degrees. It's not A because of the fact it's already at 20. So it's going to go up above 25. So I would think it'd be B. Okay, so number one was C, two is F, three was B. And that's all you have to do for the onset for today. Okay, so make sure you post your reply. I want to make sure you get that in by midnight so you can get your 2 points in your attendance artifact. And that'll kind of take care of today. Any question on the two graduate cylinders? Okay, I'm going to go back to modules. On the modules, like I said, we're going to go over the week and what's coming up this week before we get to our assignment. And to do that, I'm going to use the to-do list I updated Friday for this week. And if you click on the to-do list, and you can just hear me out if you're adding your onset. Today, we're going to take care of the video with the Chem 202. You guys have seen this gentleman before. He does a very good job of reviewing the stuff we talked about with atomic structure. And I think a review is a very necessary thing today since we haven't had direct talk with this since Tuesday of last week. Okay. Tomorrow we are going to get into looking at the practice packet. Okay. And if we're still remote, I suggest you attend the live lesson so I can explain it to you. That one's going to take a little bit. That's 40 points. There's 4 pages. They're 10 points apiece. And I'm going to give you Wednesday, the remote day on Wednesday, to finish that practice packet and turn that in. So you have tomorrow and you have Wednesday to finish that assignment. Thursday, I plan to move the build an atom simulation till then. Okay, and that is using one of those PHET websites that do the simulations. We're going to build an atom with buckets of protons, neutrons, and electrons. And then we're going to ask you to do some different things. And then Friday is going to be open notebook, open Google Docs atom quiz. So make sure you have your notes that I shared with everybody for it was in last week, it would have been week 20. And then make sure you have the notes from when we had the discussion last Tuesday. You might have to watch the live lesson, the recorded live lesson that I gave everybody to get the rest of the notes for the second section. Okay, so that's kind of where we're going with this. Open Google Docs, which means you can have the Google Doc open and take the quiz at the same time and use that resource as you to help you. But that's going to be 40 points as well. There's 20 of them. I'll give you 2 points a piece for them. Okay, so we're going to be adding quite a bit to start off the 39 weeks. You want to make sure you keep your head above water the best you can. Okay, get a good start. Work hard this week, and it's going to give you a good foothold on doing well the rest of the way. Okay, any questions about what's coming up this week? Okay, you got a clean slate for yourself with the new 9 weeks, so you got to make the most of it. I'm going to go back to modules. I'm going to get the rest of the time to take care of your assignment here. It says Chem 302 video fill in the blanks, and you'll see what I mean by fill in the blanks in a second. It says use the PDF attached, and it's going to be in Cami. It's going to be down here in the gray rectangle. When I would open up this in a new window and open up my my link to the video in a new window, or a new tab rather, so you can kind of toggle back and forth between them, because you're going to need to do that to answer these questions. And then open using Cami and annotate the document to fill in the note-taking guide that goes with the video on atoms. And I'm going to give you like the first couple here to kind of send you on your way. After you're done, you'll save it to your drive, and then you'll turn it into me and hit submit. I want this done by the end of the day today, February 1st, for your 20 points. And that'll kind of lead us up into making sure that we don't get too far behind, and we can focus just on the Adams Family packet for the next 2 days. Okay, so you should open this up, like I said, the video in a new tab, and open up your Cami assignment in a new tab. I have both of mine open here. Here's my Cami assignment, and I'll give you about a minute to open both these up. Okay, and what you're going to do is he's going to put stuff on the, it's like a green chalkboard on the screen. When it comes to a certain point, and he's kind of going chronological order from the beginning of the video to the end, you're going to type in what you need for your notes. Okay, and this will kind of help you stay focused with what he's going over with you. Okay, and then the other tab you want to have open is the actual video itself. And it'll say Chemistry 302, the structure of the atom. And we're going to start watching this, and once it gets so far, I'm going to fill some of these in with you, and then I'll kind of leave it go, and then you can have the rest of the time to finish this up. Okay, but they put them right on the screen. You just kind of have to go back through and kind of stop it, type it in, go back, okay, and then go through it that way. After you finish this, you should have a very, very good review of everything we talked about on Tuesday and the parts of the atom. Okay? Any questions before I start? Okay, let's start this then. I'll turn my volume up. I'm going to hit play. And then I'll stop it when it's time to put some answers in. Okay, but I'm not going to be able to do all of it because we don't have enough time. We got to be out here in about 12 minutes. Okay, so your job is to finish the rest of this for tonight.
Check out our new series, Chemistry Matters, aligned to the latest Georgia science standards. Available now.
There's only one ad.
Oh, I'm glad you're back. If you recall, the last time we met, we discussed the idea of the atom, starting with Democritus and his thought experiment that stated that atoms simply existed. We stopped with Rutherford's gold foil experiment that led to the planetary model of the atom. Soon we'll learn about Bohr's ideas about Rutherford's model, but not right now. Today we're going to, yes, you guessed it, dive into the structure of the atom.
During this lesson, you will define the terms isotope, atomic number, mass number, and atomic mass. And you will be able to determine the number of subatomic particles in an isotope of an element.
So, Rutherford's planetary atom consists of a positively charged nucleus surrounded by an electron cloud. Remember that we're still going to make adjustments to this model of the atom in the future, but for now, we'll use the model to discuss the three main subatomic particles. The particles that make up the nucleus of an atom are called nucleons. That makes sense. Nucleons are in the nucleus.
Now, once this stuff comes up on the green chalkboard, you go back to your CAMI assignment, and it says nucleons blank in the blank of blank. And it says particles in the nucleus of an atom. So you would just type it in with the text box, particles, and some of these require more typing than others. In the nucleus of the atom. Okay, and that would take care of the first line. Now he's going to give us some more, so I'm going to hit play again. Okay, whenever it comes up on the green screen is what you want to fill in.
The two most important nucleons are the proton and the neutron. You must...
And then proton and neutron are going to get filled in to your sheet. Okay, it's not bad. It just takes, you're going to have to go back and forth a little bit. Okay, if this was on paper, it might be a little bit easier, but we don't have that luxury right now. Okay, so I'm going to play the rest of this. Are there any questions of what you got to do? That gives you the first bit. You're just going to use the text box and put the answers in. He's going to give you every single one of these answers. Okay, and when you get down to the bottom here, the chemistry quiz, or when they do the multiple choice, okay, and you pick A, B, C, D. And then you'll hit submit when you're ready to turn this in for 20 points. Like I said, this is due by the end of the day, today, by midnight. Okay, so are there any questions on what you got to do with this? Okay, I'm going to play the rest of this. You will have about 6-7 minutes, and then we can finish this up and be ready to hopefully go back live tomorrow. Okay, in person. Here we go.
Must learn to describe an atom in terms of the number of protons and neutrons it has in the nucleus. We'll also find out how to tell how many electrons an atom has in its electron cloud. The periodic table is an amazing feat of science. As a matter of fact, we'll spend an entire unit learning why the table is arranged as it is. But for now, we will use the periodic table during this lesson to give us valuable information to study atomic structure.
Every element has a characteristic number of protons. Scientists have assigned each element a specific number according to the number of protons in the nuclei of its atoms. For example, hydrogen, the lightest element, has 1 proton, making its respective number 1. Helium, the second lightest element, has 2 protons, making its number 2. The number assigned to an element is called its atomic number. The atomic number for carbon is 6, as carbon atoms have 6 protons. Similarly, uranium atoms have 92 protons, making its atomic number 92.
So, we call the number of protons in one atom of an element its atomic number. This number is listed on the periodic table for each element. All of the atoms of one element have the same number of protons and the same atomic number. As you saw, since hydrogen has an atomic number of 1, every atom of hydrogen has 1 proton. If an atom has 2 protons, it is helium, not hydrogen. Since the periodic table lists the atomic number of each element, it's easy to find out how many protons each element has. We simply need to look at its atomic number.
We call the number of protons in an atom of an element its atomic number. All of the atoms of one element have the same number of protons, and so they have the same atomic number. The atomic number of an element is like your social security number. Your social security number uniquely identifies you, just like the atomic number uniquely identifies an element.
If you know an element's atomic number, you also know how many electrons are contained in an electrically neutral atom of that element? It's the same.
Protons have a charge of +1, and electrons have a charge of -1. Since an atom is neutral, the number of positive protons must equal the number of negative electrons. That way, the total positive charge is equal to the total negative charge, making the atom neutral.
So, hydrogen with an atomic number of 1 has 1 proton and 1 electron. It is electrically neutral. Helium with an atomic number of 2 has 2 protons and 2 electrons. Again, helium atoms are neutral also, because the number of positive protons equals the number of negative electrons.
While the number of protons found in the nucleus of an atom of a given element is always the same, the number of neutrons can vary. In its most common form, the hydrogen nucleus contains only 1 proton and no neutrons, although 2 other types of hydrogen exist. One form, known as deuterium, has 1 proton and 1 neutron. Another form of hydrogen, called tritium, has 1 proton and 2 neutrons in its nucleus. It is important to remember that these 3 varying forms are all hydrogen atoms. They each have 1 proton, and therefore all have the same atomic number. Atoms of an element that have different numbers of neutrons are called isotopes. The most common form of hydrogen, the isotope known as tritium, occurs at a ratio of 6,000 to 1 when compared to deuterium. The hydrogen isotope tritium does not occur naturally and can be only made in laboratories. Of the 109 elements in the periodic table, 90 occur naturally, and the others have been produced in laboratories. All but 20 of the naturally occurring elements exist as mixtures of 2 or more isotopes, which occur in a fixed ratio in natural samples. For example, oxygen has 3 known isotopes, and mercury has 7. Scientists have derived a unit for measuring the mass of an atom, known as the atomic mass unit, or AMU. The AMU is based on the mass of an atom of the element carbon. 1 isotope of carbon contains 6 protons and 6 neutrons. This isotope of carbon is said to have an atomic mass of almost exactly 12 AMUs.
The number of protons that an element contains is fixed, so all atoms of the same element have the same atomic number. As we just learned, the atomic number identifies the element. But the number of neutrons that an atom of an element has can vary. Atoms that have the same number of protons, remember, that means they are atoms of the same element, but different numbers of neutrons are called isotopes.
Pause it there. Ms. Myers, we can talk about that tomorrow in class. Okay? You guys just want to try your best on this. Now, the remainder of this you're going to take and finish up. Tonight you got about, 18 minutes left. Like I said, you just have to go back and forth with it. Right now you're on isotope, atoms of an element that have different numbers of neutrons. Okay, so the neutrons are going to be different. We talked about that on Tuesday. But this, like I said, serves as a good review. You should be down here with your answer so far. Okay, down here. Any questions before I shut this down? I don't want to keep playing it because it's about time to go. Okay. Tomorrow, like I said, hopefully we'll be back in class, and then you can watch the recorded lesson with this. And then we're going to practice. I'm going to show you how to do the Adams Family practice packet, and that should be something that helps everybody with this. Okay.